The prospects for oscillating models were severely dimmed, however, in 1970 by Roger Penrose and Stephen Hawking's discovery of the singularity theorems that bear their names. The Hawking-Penrose singularity theorems demonstrated that under very generalized conditions, an initial cosmological singularity is inevitable, and therefore it's impossible for the universe to be oscillating from eternity, because it's impossible to extend space-time through a singularity to a prior state. Reflecting upon the impact of this discovery, Stephen Hawking notes that the Hawking-Penrose singularity theorems, quote, led to the abandonment of attempts, mainly by the Russians, to argue that there was a previous contracting phase and a non-singular bounce into expansion. Instead, he says, almost everyone now believes that the universe and time itself had a beginning at the Big Bang, end quote. And Dawkins apparently labors under the delusion that a singularity doesn't form a boundary to space and time. In any case, even if the universe could somehow oscillate from eternity past, such a universe would still require an infinitely precise fine-tuning of its initial conditions in order to persist through an infinite number of successive bounces, so that the mechanism that Dawkins proposes for generating the many worlds is not simple. In fact, quite the opposite. It's infinitely complex. In fact, such a universe would involve fine-tuning of a very bizarre sort, because the initial conditions would have to be set at minus infinity in the past, since there is no beginning to the universe. But how could that be done? How can you set initial conditions if there was no beginning? It seems to be logically incoherent. Now, Dawkins' second suggested mechanism for generating a world ensemble is Lee Smolin's evolutionary cosmology. According to Smolin's hypothesis, black holes in our universe are actually portals to baby universes which are birthed by our universe. Universes which produce lots of black holes would therefore have an evolutionary advantage by producing more offspring. The more black holes a universe has, the more baby universes it produces, and so these kinds of universes would become more and more numerous as time goes on. Now, since black holes are the result of star formation, they are the final state of stars, and since stars promote planets where life could evolve, the unintended effect of evolutionary cosmology is to make life-permitting universes more probable. So, Smolin says the fact that the universe is life-permitting is just the unintended consequence of his evolutionary cosmology. Now, Dawkins acknowledges that, quote unquote, not all physicists are enthusiastic about Smolin's scenario. Talk about an understatement. For Smolin's scenario, wholly apart from its ad hoc and even disconfirmed conjectures, encountered insuperable difficulties. First of all, a fatal flaw in Smolin's scenario was his assumption that universes which produce lots of black holes would also produce lots of stars. And in fact, the exact opposite turns out to be true. The most proficient producers of black holes would be universes which generate primordial black holes prior to star formation. And therefore, these kinds of universes would have an evolutionary advantage, so that life-permitting universes would actually be weeded out by evolutionary cosmology. Thus, it turns out that Smolin's scenario would actually make life-permitting universes even more improbable than otherwise. Secondly, speculations about the universes begetting baby universes via black holes has been shown now to contradict quantum physics. The conjecture that black holes may be portals to wormholes that allow vacuum energy to tunnel through the black hole to spawn a new expanding baby universe was the subject of a bet between Stephen Hawking and John Preskill, UC cosmologist, which Hawking finally admitted in 2004 that he had lost in an event much ballyhooed in the press. The conjecture that black holes are portals to wormholes through which energy can tunnel to form baby universes would require that the information going into a black hole could be forever lost from this universe into a baby universe. And one of the last holdouts, Hawking finally came to admit in 2004 that information is preserved in black hole formation and evaporation. The implications, I quote from Hawking, "There is no baby universe branching off as I once thought. The information remains firmly in our universe." I'm sorry to disappoint science fiction fans, but if information is preserved, there is no possibility of using black holes to travel to other universes, end quote. So what that means is the Smolin scenario is literally physically impossible. It contradicts the laws of quantum physics. Now, those are the only mechanisms that Dawkins suggests for generating his world ensemble. Neither of them is even tenable, much less simple. And therefore, Dawkins has failed to turn back the objection that his postulation of a randomly ordered world ensemble is an unparsimonious extravagance. But there are even more formidable objections to the world ensemble hypothesis, of which Dawkins is apparently unaware. First of all, there's no independent evidence that such a world ensemble exists. Moreover, recall that Borg, Guth, and Vilenkin proved that any universe which is on average in a state of cosmic expansion cannot be infinite in the past, but must have an absolute beginning. Now, here's what's interesting. The Borg, Guth, Vilenkin theorem also applies to the multiverse, to the whole world ensemble. It, too, therefore, must have an absolute beginning in the finite past. And therefore, since the multiverse's past is only finite, that means only a finite number of universes may have been generated by now in the world ensemble. And therefore, there's no guarantee whatsoever that a finely tuned universe would have been produced by now in the ensemble. Secondly, and even more devastatingly, if our universe is just a random member of a world ensemble, then it's overwhelmingly more probable that we should be observing a much different universe than the one that we, in fact, observe. Roger Penrose of Oxford University has made this point very forcefully. Penrose calculates that it is inconceivably more probable that our solar system should just fall together instantly by the random collision of particles than that a finely tuned universe should exist. In fact, Penrose calls it utter chicken feed by comparison. So, if our universe were just a random member of a world ensemble, it is inconceivably more probable that we should just be observing an island of order no bigger than our solar system. Observable universes like that are just vastly, vastly more plentiful in the world ensemble than finely tuned universes like ours, and therefore that's the kind of world that we ought to be observing if we're just a member of a randomly ordered world ensemble. Now, since we don't have such observations, that strongly disconfirms the world ensemble hypothesis. In fact, Penrose is very blunt about this. He says that these world ensemble hypotheses are worse than useless in explaining the anthropic fine-tuning of the universe. On atheism, at least, then, it's highly probable that there is no world ensemble. So, the fine-tuning of the universe is therefore plausibly due neither to physical necessity nor to chance, and it therefore follows that the fine-tuning must be due to design, unless the design hypothesis can be shown to be even more implausible than chance or physical necessity. And indeed, Dawkins does contend that the alternative of design is inferior to the many worlds hypothesis. Summarizing what he calls the central argument of my book, Dawkins says that even in the admitted absence of a strongly satisfying explanation for the fine-tuning in physics, still what he calls the relatively weak explanations that we have at present, namely the world ensemble hypothesis, are, and I quote, self-evidently better than the self-defeating hypothesis of an intelligent designer, end quote. Really? Well, what is this